Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are here today at Fremont Elementary School, home of the Falcons, and today we're all here to do the math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
And in studio with us, we have a returning student, Elizabeth, a 6th grade student. Everything well today? Mm-hmm. All right. Well, you know the rundown. If somebody wants to get a hold of us, what do they need to do?
Call for math homework help in Bakersfield, 636-4357, toll free, 1-866-636-6284. Our email is dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
So how have things been since last week when we saw you the first time?
I got all of my math questions right.
I know. I said, see, this is beautiful because what we'll do is we'll put this under the camera right here, and we can see that Elizabeth got a 100% on her math test, probably because you were here last week, don't you think? Mm-hmm. And then there you go. I'm sure you had a lot to do with it, but we'll take a little bit of credit for that also. So you ready to show a little bit of your expertise?
Yeah.
All right, over to the board, young lady. Here we go. First one, because there are some students that need to fix their math test and working on equations. Mm-hmm. So since you've got this pretty much under control, we're going to have you explain to Marylou how to do these problems. So the first one, 6, and then open parentheses, x plus 2, close parentheses, minus 4x is equal to 48.
All right, go for it. Tell me how to do this.
So first you need to multiply 6 times x. And we do that because 6 would be times 1x.
Now, we know that you're saying the 6 multiplied, right? Mm-hmm. And I'm thinking of order of operations, the PEMDAS.
Yes.
And usually PEMDAS is to solve the parentheses first. Mm-hmm. But you can't do that, can
Nope.
you? Why? Why can't we solve the
because
parentheses?
you can't add an x to a non-x.
Do we know what x is yet?
We do not know what x is.
And is that your objective right now?
Yep.
Okay. And then by multiplying it, you're doing the distributive property, correct?
Yep.
Okay, keep going.
Then you have to multiply 6 times 2. And we would add on the 4 and bring it down.
So, in a sense, you just simplified that, correct? Mm-hmm. Okay. What's next?
Next, we need to add our x's with the x's.
Now, the x's with the x's, I know that you're in 6th grade, and next year you're going to be getting more vocabulary on this.
Yep.
These are called like terms. And think of that word, like. They're alike because they share the same variable. And that same variable means that that's going to represent the exact same number. And by simplifying those, which you're going to do next, we can do that because we're going to be multiplying.
Yep.
So how did you get the 2x?
You have to subtract 6 minus 4.
Okay. And then obviously you can't combine the 12, right? Because it's not a like term and it doesn't have an x with it.
Yep. And you have to get rid of the 12 now.
Okay.
So we would subtract 12 from both sides.
Okay, so we're not done yet, right?
Nope.
We have how many more steps, do you think?
About one.
One more step. And again, for everybody out there, the 2 next to a variable means what?
That you have to divide together.
But we're multiplying, means multiplying, right? So it means that we're saying 2 times an unknown number equals 36.
So to get rid of it, we need to divide it.
Very good. We're doing the inverse, which is the opposite. And you can write it over here. What's our x then? So therefore, wherever x is, it's going to equal
18.
18. And does your teacher require you to plug that back in and double check your work?
He doesn't require it, but most of us should do it.
Okay, do we have time to check?
We'll check one of the problems in a little bit, but
Okay.
that was wonderfully done right
Yes,
there
it
for the very
was.
first problem.
Good job.
Nicely done, Elizabeth. Well, we do have phone tutors available until 5:30, as we
me
do
to get
most
rid of it?
Tuesdays and Wednesdays throughout the regular school year. The phone numbers are at the bottom of the screen periodically throughout the program. Time now for today's Math in the News. Well, today's Math in the News, once again, we are fortunate enough to have somebody from the community come in and visit our studio. In studio with us today, Sergeant David Brooks. How are you?
Good, sir. Thank you.
Nice to have you in.
Thanks for having me.
I said Sergeant David Brooks, so where do you work?
So I am a sergeant with the Bakersfield Police Department.
Okay, and you're not here because you're a sergeant with the Bakersfield Police Department, but mostly because of what's on your shirt, the Police Activities League.
That's correct.
So tell us a little bit about that.
So I'm currently assigned to the Bakersfield Police Activities League as my assignment. We are a nonprofit organization. We focus on combating juvenile issues in the community. We look to enrich the lives of our kids in our community, and we do that through the services that we provide to our kids at our community center.
Okay, and how long has PAL, Police Activities League, been around?
So we've been around for 25 years now. This is our 25th year, so we're excited about that.
And how did you become, like, did the police department say, all right, David, we need you to go to be part of PAL? Or do you volunteer for that, or how does that work?
So initially, when I first started working with the Bakersfield Police Department, I would volunteer my time. At this point, I was assigned to the Bakersfield Police Activities League as the executive director. So that is my current assignment, and I spend my entire week there.
Okay, so as executive director, what are some of the duties you need to take care of?
So what I do is I run the facility, I manage employees, I put together our fundraisers, manage our program. We have maybe roughly 130 kids a day, so I run the programs for all our kids that come in.
Okay, so you've got 130 students that are involved with the Police Activities League. Are they all at one site, or are these multiple sites?
We're all at one site. We have a facility at 301 East 4th Street. So we sit on six acres of land, and we have about a 17,000 square foot facility, which is amazing. We have tutoring, we have basketball, we have a game room, arts and crafts room. There's a lot going on. We have a jiu-jitsu room. We run various programs through the facility as well.
Now, are there students there every day, or do they come kind of when they want?
So our kids come in Monday through Thursday, and we start from 2 to about 5:30 in the afternoon. So as soon as our kids get out of school, they usually come over to the Powell Center and they hang out with us until about 5:30.
Okay, and what are some of the, I know that you guys are out and about in town, what are some things that you guys have done, like on an annual basis or kind of recently that you've been out doing?
So because we're a nonprofit, we get all our funding through grants, fundraisers, and donations. So we do various fundraisers throughout the year. We do such fundraisers, Battle of the Badges, where we have officers from different departments.
I remember seeing
and
that.
they fight each other, and it's all for the kids. Everything that we raise goes directly back into the Police Activities League.
Now, is that why you have jiu-jitsu at the site, so that way you get a little practice in yourself? Do you
Yes.
participate in the Battle of the Badges?
I haven't participated in a long time. Yeah, I can't do it any longer.
But you did.
I have.
And that turned out well when you were in it?
It did. So, and again, we have a great boxing program too. We actually had a couple of kids who are, well, they're not kids anymore, but they're professional fighters now, and they learned everything they have from our facility.
All right. Elizabeth, do you have any questions for David?
Yes. If I'm not in PAL, is there an event I can go to?
Definitely, we have various events throughout the year. Our community, you can come out and support us. We have an event coming up in February. I think it's February the 22nd. It's our annual clay shoot. that we'll be putting on, and it's at the Kern County Gun Club here in Bakersfield. But it's a great event, great food, a good time. All you have to do is contact the Bakersfield Police Activities League at our number 283-8880 or bakersfieldpal.org to register.
All right, you know what? Why don't you give that phone number and website again for any students and adults that may want a little bit more information on
Sure. You can reach us at 283-8880 or bakersfieldpal.org.
All right, well, you know what? We certainly do appreciate you taking out
Thank
some
you.
time.
I appreciate it.
And maybe the next Battle of the Badges, you'll get out there and you go, hey, you know what? I still got a little bit left of me. Go get it going a little bit.
I'll try.
All right. Well, thanks for that.
Thank
hey,
you.
listen, we do have phone tutors available until 5:30. That is today's Math in the News. And you were talking about your old elementary school.
Fremont
Elementary.
Falcons.
That
That's
just
my
happens
school.
to be where we're going to be going today. So let's go out and check it out.
Hey, thanks a lot, Mike. We're here today at Fremont Elementary, home of the Falcons. Got a great group of 5th graders here, and the topic of the day is division. Division. We've explored a lot of the methods that are used, and for many people, they think of division and they think of the bracket, the long division. That doesn't sound very appealing. Long division sounds like it's going to take a long time, so we try to put it off as much as possible. This is a group of 5th graders that has demonstrated understanding and familiarity with 3 different division models. Now, a lot of us think that that means that we have to lay out some boxes, do a reverse area model, utilize some other strategies. But what this group has identified are different algorithms. Now, that doesn't sound too appealing at hand, but I want you to see how this group works through all of these models and methods. So, today what we're going to do is look at division at the 5th grade level, generally dividing 4-digit numbers by 1 or 2-digit numbers. And when we do that, you're going to see that there are many different approaches you could take. So, we've got our groups of 2 right here. Everybody here is paired up so that they can discuss and make sense of problems all together. So, we're going to start off with something very straightforward. I want to go ahead and lay out one of their division problems that they have laid out for homework and see how we approach this, because there are going to be a lot of different models that we're going to explore. So, your first challenge here is 4,743 divided by 3. I want to give this group about 2 minutes to start working through this, and as they do, I want to introduce you to some of their models that they've worked with. Ladies and gentlemen, are you ready?
Yes!
Go ahead and kick things off. We had an earlier problem as a warm-up, and their work through these earlier problems led us to 3 very unique approaches, some of which have a lot of similarities. One of which we looked at first dealt exclusively with place value and worth, very similar to what we would call a partial quotient algorithm. So instead of thinking about this as 9,057, so they had to do 9,057 divided by 3, they looked at this as 9 thousands and 5 tens and 7 ones, and looked at how many 3s could fit into each of those and added those pieces together. So we look at this exclusively as 9,000. That's what that 9 represents. They asked how many 3s could we get into 9,000? 3,000. So we were able to take 9,000 of that out. We're left with 57. And you can start to conjecture how many more groups of 3 work in just 57. It's a lot simpler to break it down to those more friendly chunks. Then we looked at the long division algorithm, which I think most of us are familiar with. You go by place value and go over. 3 into 9 as far as thousandths, and then 3. And then look at the hundreds, there's 0, and then there's a lot of work. And now something interesting that I think is a ages-old frustration with the long division algorithm is the fact that it's long not just in time, but in length. It is not uncommon to run out of paper or smartboard space before you have to kind of start writing really, really tiny. One of our students here by the name of Victoria introduced us to a method that involved space saving, but allowed for some similarities with the standard algorithm. So this is what we call now the Victorian division algorithm. Yes, we're still going to do 3 into 9 3 times, and then subtract that. But instead of continuing downward, we take this value here and bring it into the tens place of whatever that next digit is. So here, it's 00, and we're still dividing, and we still do this, but now we're carrying it over here. We are doing the same division, but in a much more streamlined manner. So credit goes to Victoria and her Victorian division algorithm. So let's go around and look at some of our solutions here on how we approach this, including the aforementioned Victoria. So we're looking at a couple of ways that we got to 1,581. So we look at our long division method, very well organized, by the way. By the way, if you're panicking about the writing on the desk, these are specifically designed dry erase desks. So there's plenty of space to work with, and it'll all be clean. No problem, Mr. Rodriguez, your classroom is okay. So we look at how this structures out, and it's very familiar and very common. Very well organized. The arrows go and follow the place values. Excellent. And in fact, what I appreciate you did here is you used kind of a reference point. So can you tell us what this is over here?
It's my multiplication, so it's 1, 2, 3. Go 3
So
times 9.
for each of these factors, you show what multiple of 3 that is over here so that you can use it in your work here. So it's a great method of efficiency to get to 1,581. And I also greatly appreciate that you check that to make sure that 1,581 times 3 does in fact get us back to 4,743. So the two of you don't have to ask, is this right? You know, because it works. So here's Victoria, and I wonder how well this is going to come through on camera, but she used the Victorian division algorithm in figuring this out. So you can see, with 1, we bring over to 1, and now we're doing 17 minus 15. So the 1 actually ends up here. So we know that 3 goes into 17 5 times. And then 2 goes into the 4 that was next to it, so this becomes 24. So do you find that doing it this way helps save you a lot of space when you're working things out?
Mm-hmm.
So why do you prefer using this compared to the standard algorithm?
Because that just looks way too confusing.
So what the value here is that you're using the same structures and understanding of place value and pretty much doing the same thing with all of the values, but utilizing a more compact and efficient model of long division here. So if anybody ever tells you that that's not how the way you do this, you tell them to go check through the math because you've got the evidence. Wonderful job. We're going to send it right back to the studio, and we're going to come back with a little bit more exploring division with larger numbers. But for now, Mike, take it away.
All right, thanks for that, Devin. We'll check in with the Falcons in just a little bit. In studio, we have Elizabeth with us, the 6th grade student from Buena Vista, correct?
Yep.
A bulldog. Mm-hmm. All right, get back to the board, bulldog. Here we go. 3, open parentheses, 2x minus 5, close parentheses, plus 2x equals negative 7.
It's all yours.
First, you have to multiply 3 times 2x, and you would get 6x. And then you have to do the same thing with the negative 5, and you get negative 15.
And that's really important to remember because this is probably a misconception a lot of students do. They don't do the negative 15. They'll probably put like a plus 15.
Because anytime you multiply a negative times a positive, it's always a negative.
Very good.
And then you bring down the 2x, and the and it equals negative 7. Then you want to add the
Like terms?
the like terms. And you get 8x positive. And you bring down the negative 15, and it all equals negative 7.
Okay, and we're not done yet.
Nope. We have to add 15 because it's already a negative, so you have to add 15 to both sides.
Do you think right here that this is another misconception where a lot of students might make a mistake?
They would probably just keep adding down and put a negative. But it's going to be a positive because the positive is bigger than the negative.
Very good. And what
And
else
then
do
you would bring down the positive 8x.
And our last step?
Divide. Divide positive 8 to positive 8. So x equals 1.
Very good.
All right, you're on a roll. Here comes another one that you said a lot of students were having a problem with this one. So let's go ahead and do this one. 4, open parentheses, c plus 3, close parentheses, minus, open parentheses, c minus 1, close parentheses, is equal to 64.
So you were saying a lot of students had difficulties on this. What do you think where are they making their mistake?
I think their mistake was probably with the C's. They probably kept forgetting to add the ones.
Okay.
And along with this open negative.
Okay. So solve this, do the distributive property and solve this side first.
All right. You have to multiply 4 times 1c, which you get 4c. And then you have to multiply 4 times 3, which is 12. Then you have to multiply negative 1 times 1c, which would be negative 1c. And you'd get positive 1 because a negative times a negative is always a positive.
And like you said, I think this right here is probably the biggest mistake. Probably a lot of students were saying minus 1.
Yep.
Okay.
And it all equals 64. Next, you have to add our c's, the equal ones. So you would get 3c because 4c minus 1c would be 3c because of the negative. And then you would get positive 13 from adding the 2. Then that all equals 64. You have to get rid of the 13 on both sides. Well, not get rid of it, but you have to subtract 13 from
We're
both
doing the
sides.
inverse, right? Okay.
So right now we have 3c equals 51, both positives.
And real quick, 51, that is like one of my favorite numbers. You know why?
Why?
Because a lot of students think that that number is prime, and it's not. It's a composite because 3 can go into it. Okay, I'll let you finish it off.
And then you have to divide both sides by 3 to get rid of our 3c to put c by itself.
You gonna do a little long division for us?
Yes.
And you like the standard algorithm. We were
Yep.
kind of talking about that earlier, huh? There you go. Boom. And again, just to remind the students, when we have an outside negative,
Yep.
your trick to put the,
Put the 1
okay, and you will be successful, huh?
most
All right.
of the times, but you also want to check your work and make sure.
Yes, which is most important.
Right, and
Yeah.
we will, I promise you, we will do one where we're going to do that, but I have a little bonus for you today, all right?
Okay.
So clear the board, ladies.
Okay.
Here we go. Here's the problem. Let's take a look at it together. Maybe the kids at home can solve it while you ladies are doing the same. What is the only positive 2-digit number that is equal to exactly twice the sum of its individual digits? So you can write down any clues you like. The only positive 2-digit number that is equal to exactly twice the sum of the individual digits.
A plus B.
Yep.
right?
Yes? Okay, so
So once again, you've got stuff written up
is
there.
it 11? Because
Because it would always double.
double, because one, oh wait, hold on,
11 times 2 would be 22.
22, and 2 times 11, because doubling the number, yeah, is 22, and 1 plus 1, oh, that's 2. That's not going to work.
So it worked for part of it.
It worked for part of it, yes.
So now get the other part of it.
Nine plus, so you're thinking of the number 93?
No. 11, this would all equal 11. 11 times 2 would be 22.
But that would be 92. The number would be 92. Do you see what I'm saying? The 2-digit number. Like here, I thought of the number 11. Okay?
Yeah. So 11, but how would we get 11?
See, exactly. So 11 doesn't work. We found it,
No.
we proved it doesn't work. So I don't know, let's go to 23. So we know that, nope, that's not gonna work either. So it has to be a 2-digit number, correct, Mike?
Correct.
Yes? It's got to be under 20.
Under
I think
20.
it's under 20 because we're timesing it by 2. We're doubling it.
15, that would equal 30.
Well, you just try it.
Well, let's try 10. What about 10?
10.
10 times 2. Well, that's not going to work
20.
because 10 times 2.
So it has to be less than 10.
No, it has to be a 2-digit number.
Oh.
It has to be 2-digit because
Not 11. So here's our not. So it can't be 10. It can't be
be
11. And it can't be.
Oh,
it has
try
to
12. Nope, that's not going to work because that's times 2 is 24.
be. And it has to be under 20.
Mm-hmm.
So why don't we just go up?
Why don't we go up? You want to
So
try
12.
You want to try
Did
19?
we try 12?
Let's try 9. We did. It doesn't work because that equals 3. Try 19.
19. 19 times 2.
What's 19 times 2? Well, 20 times 20 is 40. Take away 2, which is
38.
38. And that's not going to work because 1 plus 9 is
10.
10. So 19 doesn't work.
So not 19. So that narrows it down to 18, 17, 16, 15, 14, 13. 13?
You're getting closer.
Ooh.
It's in
right.
there somewhere.
It's in there. So it is under 20.
Oh,
we
it
have
is.
that correct.
I'll give you that. It's under
Oh, we
20.
have it. Okay, so we're getting close.
26 plus 1 be 27.
So 13 plus 2 is 15. Let's try 15. 15
So not
times 2
13.
is 30, right?
Yep.
And 1 plus 5 is 6.
36. If you add the
Try 16.
16. $32.
So, and that's, nope, 6 plus 1 is 7.
So what haven't we done? We've done 15 and that doesn't work.
We did 13.
We did 13 and we just did, what did we do, 16?
Yep, and we did 15.
So 17.
Try 17. That's 8. Are we going the wrong direction?
You're fine. Keep working.
Okay.
34.
And let's see, 7 plus 1 is
8. 7 plus 1
is 8.
8.
I'm not seeing where, and we did 19 already, right? We did 19, we did 18.
No, you didn't.
We didn't do 18. 8, 9.
Oh,
But see, 18 times 2 is 36, and this is 1 plus 8 is 9. What is the word problem again? It
Now let's take a
says-
look at the problem again. The only positive 2-digit number that is equal to exactly twice the sum of the individual digits.
Oh!
did we do something?
Wait.
You just did.
Right here. We just did it. It's 18. Yes?
Okay, now take a look at it again because I think you may have stumbled upon it, but aren't really sure why you stumbled upon
Okay,
it.
hold on. What is the only positive 2-digit number that is equal to exactly
twice the sum of its individual digits.
So the sum means you're going to add them,
Yes,
okay?
we did.
So 1 and 8 is 9.
9.
If you take twice that, what do you get?
9
18.
times 18. Oh, twice
You don't even
of
need the
this.
36, what you girls were doing before. It was lovely to
got it.
watch, and I just wanted to see how you went through that process. But in order for doing all of that work, you made me a little hungry, and I'm sure you're hungry as well. So, Elizabeth, we're going to award you with a meal of your choosing at our friends from Grillin' Burgers. So, congratulations on that. And we'll be back with more right after this. Today we're at Kernville Elementary School, home of the Mountaineers, and we're here to Well, today we've got some 4th and 5th grade students at Kernville Elementary School, and we're going to do a little bit of math. You guys ready? Yeah. All right, here we go. So, the first thing, how many of you have ever played golf? A little bit? Like on a real golf course or just the miniature golf?
Miniature golf.
Miniature golf?
Miniature golf.
You swing the big clubs, you're out on the tour all the time? I'm only kidding. So, anyway, golf, the scoring in golf is a little different. Do you guys have any idea how they score in golf?
Get in the hole.
Get in the hole, but you count how many shots it takes to get there, right?
Yeah.
And you want a low score, right? In a lot of sporting events, you want to get a high score. But in golf, you want to keep a low score, because if we're shooting and it takes you 3 shots to get in, and it takes her 4 shots, who did better? You did, because you did it in only 3, okay? So think about that as you want a low score when we're doing golf, all right? You, young lady, are going to be partnered up with me, all right? So you two will play together, you two will play, and then you two will play, all right? And Bella, you're stuck with the old man, is that all right? Okay. So for each pair of you, you're going to get 2 dice. Are you good with red and green? Mm-hmm. Okay. So, the first person will roll the dice. Okay, so I'll roll, and I'm going to add them up. Now, when I add those up, what do I have?
8.
8. So what I'm going to do is I'm going to make a little mark so that it adds up to 8. Now, how can I do that? How can I get to 8 using these numbers?
5 and 3.
I could use 5 and 3. What else could I use?
7 and 1.
7 and 1.
6 and 2.
6 and 2. Could I just use 8?
No.
I could.
Oh,
I could just use 8. All right. Could I go 4, 3, and 1?
No. Well, yes.
I could, right? As long as it comes out to 8. You can use any combination of numbers as long as you're adding them. You can't subtract them. Okay? You go ahead and roll. So you have how many?
10.
Okay, so you figure out how do you want to mark off 10. There's a lot of different ways you could do it.
5 and 5.
Well, you can only use 5 once because it's only there once.
9 and 1.
So you want to use the 9 and 1? Okay, so what you'll do is in this corner, you'll mark the 9 and the 1. Okay? And then it would be my turn, right? I roll the dice and I mark on my paper the ones I want to mark. Okay? And then it's Bella's turn. All right? Now, when Bella goes again, she can mark off any numbers that haven't been used yet. All right? Make sense? She can't use the 1 anymore and she can't use the 9 anymore. As soon as you're through, you can't go anymore. Like if she goes, oh, I can't go anymore, I've gone 3 times and I'm done. Then you're finished. Then what you're going to do is you're going to take the numbers that don't have a mark on them and add them up. And that's going to be your score for round 1. Go ahead, first person roll, mark off whatever numbers you like that add up to that. So the 2 numbers you have left are 4 and 5. When you add them up, what do you get?
9.
All right, so that's your score for round 1. So you're going to put a 9. All right? You guys all getting close to ending your first round?
Yeah.
Okay. So the way this goes is you play however many rounds you want, okay? And at the end, as long as you both have done 3 rounds or 4 rounds or whatever it is, you add up your score. The person with the lowest score wins. All right? And that, just an easy way to learn how instead of always getting a high score, you want a low score with a little bit of golf and the 4th and 5th grade students at Kernville Elementary. And a big thanks to the staff and students at Kernville Elementary School. We do have phone tutors available until 5:30 this afternoon. We have Elizabeth, a 6th grade student, in studio with us working on some equations and some riddles and some other stuff coming up a little bit. But first, we're going to head back out and see what the kids are doing at Fremont Elementary.
Hey, thanks a lot. Back here at Fremont Elementary with our wonderful group of 5th graders today, exploring division. Now, we got a chance to explore another model that maybe you haven't seen before in our earlier segments. We call it the Victorian method. And I was curious. I had to jump in. I really hadn't seen it before, so I had to, of course, question the wisdom of the ancients and of the wise and make sure that it worked for me. So, we gave our class another division expression to have them solve it. And I worked through it myself using the Victorian method. Thanks, Victoria. So, we got 948. We worked it through. Couldn't do anything with this 4 in the thousandth place, but we were able to combine 4,700 into 4,700s and then work through it from here. And very much like the rest of the class, we ended up with 948, but that's not all. For most of what we've seen, I saw this at the end. R3. Now, R3 sounds like the most boring Star Wars robot in the universe. What does R3 mean? Let me get some hands here. Okay, what does R3 stand for? And I want to hear some different ways that you make sense of this. Here and then here. Go ahead.
It means remainder. R means remainder.
It means remainder.
It's the same thing I was gonna tell her. It means remainder, but it also means it's like an extra number that is 3, so you put it on the side of a different part of the family.
So when you say remainder, what you say, it's a different part of, you say the family?
Yeah.
Oh, it's a family, you guys. I love this number family. You guys are like my number family. So when we say it's extra, and then it's remainder, we mean that it's left over. But how much is an R? I think we use that letter R to represent remainder without really making sense of what that 3 really is all about. So why do we have a 3 there? You said it was extra. You said it was a remainder. What are your thoughts here? Yes?
The reason that we have 3 is because we don't have an extra number that would fill in for the 3.
So what you're saying, I think I get what you're saying, is that we're trying to get groups of 5. Because what division is taking a larger number and creating equal-sized, smaller groups. If I have 4,743 things, I want to know how many groups of 5 things I could make out of that original amount. It could be jelly beans, it could be potato chips, it could be any type of food that apparently is very popular in math problems. You ever notice that? Most word problems involve some sort of candy or cookies or something you gotta eat. I've never eaten that much in math. Always very curious. But whatever groups we're making, when we get all of our groups, we got 3 things that don't fit into a group of 5. Now, how big are we trying to make our groups? If we're dividing in this expression, how big are we making these smaller groups? If I'm dividing by 5, I'm taking my larger number and I'm creating smaller groups of what?
5.
5, right? Well, with this last group of 3, I don't have a full group. I want to do something. I want to change our mindset a little bit. I know we've been working a lot with division, but I want to shift into the world of fractions a little bit. And I want to think about this last set. When we think about fractions, we think about part compared to the whole. If I had a whole group, how many things would be in that group? 5, right? 5. So that would be my denominator if this was a fraction. But I don't have 5 things for a whole group. How many things do I have? What's left over? 3. So, part of our last group is the 3 that are left over. Might I suggest to you, if we want to move beyond the world of remainders and express our answers in a more mathematical sense, You have dry erase desks. I'm going to dare you to do something. I dare you to erase the remainder.
What? No.
I'm so sorry, you guys. Believe in me, we're gonna do this. And replace it with our fraction. Because we have 3/5 of our last group remaining. 4,743 divided by 5 isn't simply remainder. We don't want to treat that last 3 like it's left over, like it's a remainder. We want to treat it like it belongs, that it has value, that it's a part of a group that's just not yet complete. 3/5 is what that remainder 3 is worth. That is 3/5 of that last group that we just can't complete yet. When we talk about remainders, it's not just something off to the side. It has value. And often overlooked is the sense that this can be represented with a true value, a fraction, a part of a whole group that is not yet complete. When we come back, we're going to play around with division and remainders and see if we can look at them in terms of decimals. But for now, we're going to send it back to the studio. Take it away.
All right, thanks for that, Devin, and we'll check in with the students at Fremont in a little bit. So here's the last equation problem I'm going to have you work on. And this is one that a lot of students, there were 2 answers. Mm-hmm. They either put down the correct one or the incorrect one, but it was always just one. It's not like there were 17 different answers. So here we go.
That'd make it more easy.
We'll find out here. 4x minus, open parentheses, 3x plus 11, close parentheses, equals -11.
Okay, first off, just looking at this before we get started, where do you think the students made a mistake right off the get-go?
This.
What do you think they were doing wrong with this?
They forgot to put the 1.
Okay, do you think a lot of them were just distributing the 4x to everything?
Probably.
Okay.
They probably just thought this was an error on the page or something.
And you're not supposed to be doing anything with the 4x,
No,
right?
you just want to bring it down.
Okay, keep going.
Then you would multiply -1 times 3 and get -3x. And then you would multiply -1 times 11, which you get -11. And then it's all equals -11.
Okay, I'm going to do a little arrow so we see that visually, okay? So we're saying -1 times the 3x, and we're distributing the -1 again to the +11.
Yep. The next thing we want to do is we want to put our like terms together. Then you want to get rid of our 11. So you would add 11 because it's a negative.
Do you think that maybe this is another step they could have possibly got tricked up on?
Probably.
Instead of adding 11, do you think they might have brought this down to 0? Well, it is 0, isn't it? Or I should say 22.
Because 1x is basically just x.
Yes.
Because even if you divide 1 by 0, you still get 0.
Yeah. But like I was saying, not, well, 0 is the answer, but here they could have possibly added.
Yeah, they could have.
Right, so here's what I want you to do. So we know that 0 is the answer. So what I want you to do is quickly check that.
Finally checking.
Yay! Okay, so let's go
so
ahead.
This would be now 0, 0.
Here, I'm going to go ahead and change that for you. There you
Okay.
go.
Or not.
Okay, keep going. Here, use this one.
Okay. That works. 0 and 0. Now you're going to multiply all of it. So 4 times 0 is 0. And then -1 times 3 times 0, which is 0. -1 times 0 is 0.
Could you, instead of doing the distributive property, could you now solve the parentheses first?
Yeah.
And then multiply by -1? would we get the same thing?
Yep.
Okay, so we have 3 times 0, which is 0.
0.
And 0 plus 11
is 11. So
Okay.
11 times -1 is -11, which equals -11.
There we go.
All right, so nicely done. So we know that 0 works, and that's the answer.
Yep.
Erase the board. You are now going to rewrite the problem. So I'll read it to you again. 4x minus, open parentheses, 3x plus 11 equals, close parentheses, equals -11. Now what I want you to do is I want you to do that problem so it comes out to the way students that got it wrong always got 22. Now, I know you were
22?
kind of on the hint of that later on,
Okay.
but I need you to show how a student would get 22 for this answer.
What do you think? Where do you think that would have gone wrong, where they would have had to do a positive?
Well, first, they probably would have not realized this and done 4x times that.
Okay.
So let's just say they got rid of it. So 4x times 3x is 12x, and 4x times 11x is 44x, which equals -11.
Okay.
Now you would add that and get 56x equals -11, and
Are we going to get 22 out of this,
No.
though? Okay, so let's go another route, because I don't think we're going to get there. Let's go back to here, okay?
so maybe we should go to the other method we thought people could have gone
Right,
wrong
if-
with the 11.
Right, if we bring down the 4x, assuming they have this correct,
Yeah.
okay?
And
we-
then the 1.
We bring this -3x, but we leave this
Positive.
positive, okay? Because they're forgetting to do the second distributive.
Oh, because they don't see a sign right here, so they
Right.
just assume add the sign
So
there.
they remember this, okay? They remember to take this away. They're probably just taking the parentheses away.
Way.
And so they're coming up with this. Now, again, we have our x, 1x,
1x plus 11
equals-
equals -11. So they're like, oh, I got to get rid of the 11, so -11. So I add -11 here. -22.
would give us a negative
22.
So
There you go.
again, it's really important that this negative, like you said, make sure you're distributing that -1.
And a negative times a positive always equals a negative, and a negative times a negative always equals a positive.
Very good.
All right, erase the board. You did that one so quickly, you have an opportunity, see, it's an opportunity for you to show us another one, all right? I will let you choose. Would you like to do number 6, 7, 8, or 9? I'm not gonna let you look at them though.
7.
7, here we go. 3, open parentheses, x plus 4, close parentheses, -5, open parentheses, x minus 1, close parentheses, is equal to 5.
5. There you go.
And I will give you 3.5 minutes.
Ooh. Okay.
Go.
So tell me what you're doing.
So you have to multiply the 3 and the x, and then the 3 times the 4. Then you have to multiply -5 times x, which you'd get -5x. Then you have to multiply -5 times -1, which you'd get +5, because a negative times a negative is always a positive, and that all equals 5.
Okay, so what are like terms? Because we have more than one set of like terms here, don't we?
Like terms are two numbers that have the same variable.
Okay, so show me your two groups of like terms.
This is our first group, and we have to add those, and you get -2x.
Why is that negative?
Because it's the higher number, so 5 minus 3 is always 2.
Okay.
And then you would get our other like terms, 12 and 5, and you'd add those together and get 17 positive. And that all equals 5. Next, you have to get rid of the 17. So you'd subtract 17 from both sides. So -2x equals +12.
Now hold on, sister.
Wait,
yeah.
hold on. We have a negative here,
Yeah,
right?
yeah.
And you have a positive here.
Mm-hmm.
So you said, yeah, -2x equals +12. What is what's our x then going to be?
Well, hold on, before you
Hold
even
on.
go that far.
Did we?
I think I made a mistake.
Hold
Yeah,
on.
because you were going so
Oh.
fast. This is what
Yeah.
happens when you go
Minus.
fast.
negative.
It's a negative there.
There you go. And that will make all the difference in the
Yes.
world
Yeah.
on the answer.
So don't rush. As in, so you have to divide -2 divided by -12. And you'd get x equals +6.
Because a negative and a
Negative always equals a positive.
a positive.
Right.
All
And I
right.
wanted you to go through that quickly because I knew you could do it quickly, right? And you now know you can do it quickly.
Yeah.
But when
Check
you're
your
doing it
answers.
quick, you also need to make sure that at the end of the problem, you take that extra 20 seconds or whatever it is and check the answer. Because if you had -6, which it would have come out
Yeah.
the first time,
Yep.
99% of the students will go, oh, -6, it's a nice number, it comes out fine. And then just leave it, which
Yep.
is why you need to make sure you check it to make sure. But you caught yourself before we got to that point right there. All right, well, you know what? For some great work right there and the added bonus problem, you've got yourself a couple of tickets to go see the Bakersfield Condors. So congratulations on that. Have you ever been to a Condors hockey game?
Yep.
You have? Have you been to one this year?
Yep.
You have? When did you go?
On Stranger Things night.
When was that? Like opening night or something like that? Is
I
it
have
recent?
no idea.
Because the season just started, right?
Ye-
I think it just started
I
recently, like in the
think.
last couple of weeks, maybe.
It was.
So what did they do for Stranger Things night?
It wasn't really anything. It was. They did trick or treating for Halloween, so it was before Halloween.
Okay. So you had fun.
Yeah.
Well, that's all that matters. Well, you're going to go again and hopefully have as much fun as you did the first time. All right, we do have one more opportunity. We'll go on out to Fremont Elementary and check in with Devin and the kids.
Hey, thanks a lot. Wrapping things up here at Fremont Elementary, this 5th grade team has really opened up a lot of eyes as far as how we look at division of larger numbers to smaller numbers. We've looked at different algorithms and models for dividing. We've looked at ways to reconsider that remainder as a fraction to be more precise about what that value is. This is a group that has demonstrated that they are ready for anything, which is great because I'm anything. And I've got one last problem to work with them today. We've been living a lot in the 4,000s with our main divisor here. We're going to change it up. We're going to work down into the 2,000s, but I have a mystery number that we're going to be dividing by. And they said that they were ready for anything. And so let's see what that looks like. Let's get your markers ready to go. Some of them have already started with the structure to see whatever that mystery number is. And I think when we reveal it, we're going to have a variety of reactions. Here it comes.
What?
That's right. 10. Ladies and gentlemen, let's see what you got. Here we go. So, there were audible gasps, as I'm sure you were able to pick up. The reason being is that for many of them, this will be the first time that they're trying to apply this concept with a 2-digit divisor. So, we'll see how that looks regarding a lot of the models that look in place. And we also made sure that we're dividing with a number that's going to have a remainder. We talked a lot about how we can represent that with a fraction. Now let's see if there's something we can do with that fraction. Let's go around and see how our teams are approaching this. I noticed that we are working with multiples of 10 here. Could you talk a little bit about your plan?
So I'm going to try to find that 10 multiplied 2 equals. So I'm
Okay,
gonna
so
try
you want to
find
make sure you have your multiples ready to reference in case you need to apply them here when you divide,
Yeah.
okay? Let's check in over here. We see kind of a modified version of the Victorian method, and you have a solution here of 293 with a remainder of 1 that then you were able to convert into a fraction of 1/10. Now we're going to hold on to that because I see that you were able to apply that same Victorian method even though this was a 2-digit number. So, hold on to that because I think that's going to be really valuable to bring forward. Wonderful job here. There's a lot of different approaches that we're seeing. Okay, so over here we see the long division method and we're subtracting. We have 9 left and then we're bringing that 9 down. So, same structure here. Okay, good progress. Keep going here. So, a couple of different approaches, and it's very impressive to see everybody get to a certain point where they're all at that same quotient here. a very confident group here. So we're going to play around with where to go from there, because if you noticed, they have all but abandoned the remainder. We're living in fraction mode right now. So what can we do with that fraction to be even more precise in representing that value a little bit differently? So, ladies and gentlemen, we're going to go ahead and come back together in 4, 3, 2, 1. There is a variety of solutions here. Actually, I shouldn't say that. The solution is the same everywhere, but the methods that you took were very different. However you got there, whatever path you took, it looks like everybody did something like this and got 293, remainder 1, and then I noticed that many of you said farewell to the remainder. And you rewrote that remainder as 1, because you had a remainder of 1, 10th, because we're dividing by 10. So we had 293 and 1/10. Now, many of you are aware that once you have fractions in the form of tens, you can turn them into a decimal, right? So, if I was going to represent 1/10 as a decimal, what would that equal?
A decimal.
So what decimal would I write for 1/10? Or how would I write that?
1 and then behind the...
So a 0.1, right? Yes. So what we're really saying is that 293 and 1/10 is the same thing as 293.1. And what's beautiful about this is once you have a remainder that you can convert into hundreds, let's say if you're dividing by hundreds, or 1,000, or 10,000, or any other multiple of 10, or power of 10 rather, you could then represent that fraction as a decimal. So we would have represented this in the past as remainder 1, but now you have done something remarkable today. You've represented solutions to division expressions as whole numbers, as remainders, as fractions, and as decimals, all in the course of one afternoon. Hey, ladies and gentlemen of Fremont Elementary scholars, thank you so much for your work today and your visibility on the program. You got a lot to be proud of here at Fremont. We're going to send it back to the studio. Mike, last time, take it away.
All right, thanks for that, Deb, and thanks to the students out at Fremont Elementary School helping us out. And thank you also to Sergeant David Brooks from the Police Activities League for coming in today, sharing a little bit of information about that. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We'd also like to thank our returning student, Elizabeth. Did you have more fun today than last week, or the same amount of fun?
More fun.
More fun. See, I didn't give you an option of less fun, right? So you had more fun today. Now, why was it more fun today than last week?
I think because I'm a little less nervous. I know what's going to happen.
There you go, a little less nervous, right? Because a lot of students, they come on, they're very nervous the first couple of minutes, but then once the show started, you were fine. But now that you've even been on the program once, now it's like, oh, this is a piece of cake, isn't it?
Yep.
All right, well, you know what? We certainly hope that you will come back and join us when you're in 7th grade.
Yep.
You can do that?
Yep.
All right, we'll look for you. Hey, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.